Here's what happened the first time I deployed a deep learning model on a real self-driving car. I was working as a computer vision engineer on autonomous shuttles. I got handed a simple task to add computer vision models to the shuttle. I started with YOLO. In about 5 to 10 minutes, I had the model working, good FPS, but then I went on to level 2, and I wanted to add a segmentation model on top of it. And this is when the problem started. The FPS quickly decreased. The GPU locked at 100%, all the cores maxed out, the temperature was burning up to the point where it crashed. If I'm just here with like 2 models, what is it going to be like when we're going to add point cloud processing, radar, GPS, planning, all the Python scripts, C++ algorithm, plus more deep learning models to the architecture? It's certainly not going to drive. It turns out when you drop the input resolution, the model can run faster, and it worked really well. Now here's what I understood much later. Resizing the image is just one trick out of an entire book of tricks. And so if this is your only tool, it's not really a tool. It's like, you know that expression, bringing a knife to a gunfight? That's exactly it. That day on the shuttle, I was what you call a player. Now, there are 2 types of engineers. There's the players and there are the pros. A player can train a model, get a data set, pick an architecture, run the training, and get a good number on some kind of validation data set. And, they think at this point the job is done. This is where they stop. A pro is different. A pro can ship models. They take your models, they get it running on real hardware, they deploy it, they optimize it. They make sure that it's going to run not just on a GPU, but on your GPU. While the player plays with deep learning, the pros ship it. Now, here's something I noticed. Most engineers in this field are players. The amount of resources on training, models, architectures, everything from universities, tutorial courses, all of it stops the exact moment the model has to go to the vehicle. And actually, it's the moment the problem just gets started. So it's not really your fault. Nobody showed the second half, the deployment part. What makes the difference between players and pros is what gets you hired. Over the past decade, I learned from some of the best in the industry, the ones who actually do this every day at very high stakes. I'd like to share 2 of them with you because they say basically the same thing. The first is a CTO at an autonomous off-road company. I asked him which 3 skills matter right now in this industry for computer vision / deep learning engineering. One of the first recommendations he gave is that AI engineering matters way more today than all the theoretical AI. His exact point was that you should spend more time getting good at deploying architectures than figuring out which architecture to use. The second is the head of AI deployment at the largest autonomous delivery fleet in the world. His entire job, his entire team is dedicated not to training models, but to make sure the models run in the vehicle. He walked me through all the tools they use. So there's PyTorch, but there is also Onyx, TensorRT, CUDA, kernels, operators. So there's 2 engineers at the top of this industry telling me the same thing it took me years to learn. The architecture is no longer the hard part. Getting it to run on the car in the real world at real-time speed, this is the job. Now, why doesn't everyone just go and learn about it? I think it's because of 3 reasons. Number 1 is I just can't do this. You think of deployment as the other kind of work. The kind done by people who spend all their time only on the terminal, they don't even have a mouse, and they run everything with Linux, they write their own custom CUDA kernels and all this weird stuff. So you see these hardcore people and you're thinking, I'm just not like that. That's one reason, and it's a valid one. Now, I thought the same thing. And what I found, learning over the years, is that the actual skills are a secret, and you can learn that secret. You take a trained model, you convert it, you optimize it, quantize it, measure it, you run it. Each step is learnable on its own, one at a time. If you look at this image, you're going to see this is the standard model on top, and this is the model at the bottom running way faster than this. If I could get from here to there, then there is actually a method of skills you can learn. The second thing people damn themselves is about C++. I'm mostly good at Python, I'm not really good at C++, so I don't really want to go on this other edge. If you're a Python person, it can honestly feel like a closed door. When you train models, and even big companies in the industry today, they don't train models in C++, they train models with PyTorch and Python. This is the way you do it. C++ often comes in production systems on real self-driving cars. I'm saying it's mostly self-driving cars like ADAS, and a bit less if you have, let's say, a drone or a robot that can work very well with Python. Together, we'll study real C++ code, the kind that pros actually ship. But let's not get ahead of ourselves, because there is a third reason a lot of people think deployment is not really for them. Deployment is simply not my job. There has to be the deployment people, the infrastructure, MLOps, and also all the people working with boring platforms. They just click, export, deploy. They don't do anything fun, right? And then there is all the people who actually play and have fun and build deep learning models, not just because they need to export something, but also for the passion of it, for the CNN layers, for the transformers, for all this passion and this fire burning. And I get it. Today, it's a bit less different. I see a lot of roles actually collapse together. LiDAR and camera, computer vision and perception, training and deployment. A lot of companies who are actually deploying models in production now go to end-to-end learning. The line between training and deployment gets even more blurred. All the training part, the parts you love, the architecture, now there's a lot of API calls, there's a lot of libraries, a lot of models pre-trained and all ready to go. It's no longer just about being the wizard doing the deep learning. It's more about being the engineer who is able to take models all the way from training to deployment. Deployment is not just someone else's job anymore, it's everybody's job. Now, what changes when you actually go through that road? The first thing is control. Right now, your model lives wherever you train them. If it's in a notebook, it's in a notebook. But once you understand deployment and optimization, you can take the models anywhere. So if it's a very small GPU, USB stick, a small drone, whatever it is, you can ship it inside of this specific target environment. You are in control. And you can run several models all at once side by side. Now, there is a second benefit to it, and it's how you look to other engineers and recruiters. Optimization and deployment are hard skills. Very few people have them. When a recruiter sees you can train on PyTorch, that's good. But when they see you can also deploy and they see all the keywords, you stop being just someone who trains model. You are also the person who can actually fit the entire job. Once you can optimize and deploy in Python, you are at the frontier of the pro world. It's not just a job title, it's owning your architecture and work end to end. Introducing the thing I wish I had back when I was on that shuttle, Neural Strike, my course on optimizing and deploying deep learning models on autonomous systems. The full path from a model that kind of works to a model that runs on real hardware at real-time speed. I started this years ago. It was a course called Neural Optimization, and over again, I rebuilt it. The optimization content is still there. Quantization, pruning, knowledge distillation. You learn to make models faster and lighter using the techniques engineers use in the field. But now, I added a second half that I think was missing, the deployment part. Onyx, TensorRT, production code, precision calibration, the part nobody really teaches. In this course, you'll do a lot of hands-on workshop in Python. You take a real segmentation model, watch it go from a few frames per second to real time, with the numbers in front of you. And you study the real C++ production code in ProShip. You're learning a complete sequence of skills that I learned here through that interview, there through that course, here with that client work, job after job, client after client. I learned it the hard way. Now, you can find a lot more details below on the price, availability, and things like that. Realize the price tends to always go up and the doors tend to close. So if the course is open while you're watching this is your moment to become a deployment engineer. So here's where you are right now. Path number one, you can keep doing what you've been doing. Training models, getting them working, handing them off to people in the deployment sectors, and hoping that's going to work. But you already know it's not going to get good enough in the long run. And even for you as a deep learning engineer, when you want to evolve, just learning how to train is not enough. On the other hand, when you learn the deployment and optimization part, you become the person who takes the model all the way onto the hardware. You're the go-to person when people actually need something working in the real world. These are the engineers who are harder to replace. And right now, very few people are becoming this person. This is an opportunity. I was a player back on that shop, with my GPU getting high and crashing and no idea what to do besides resizing the input. It took me years to get on the path to becoming a pro. You don't have to take the leap. The path is here, all in one place, and if you have good deep learning foundations, it's going to take just a few hours for you. So the access link is right below this video. And if it's open, I think you should go for it. It's time to become a deployment engineer.